Today we will be discussing unit vectors and vector notation. We first began by discussing unit vectors. So we'll draw the coordinate space in 3D, assigning x, y, and z directions. In the x direction, we have I hat. In the z direction, we have k hat. And in the y direction, we have j hat. These are the three unit vectors, x, y, z, for I, j, k. Unit vectors give us direction in the x, y, and z axes. Here's an example. We first began by drawing the x and y coordinate axes. Let's say our first vector A is given by 30 units at 0 degrees. Our second vector B is 40 units at 90 degrees. We can add vector A and B graphically by drawing the resultant. Since it makes a right triangle, we know that the resultant has to be 50 units at 53 degrees. I can rewrite vector A in several different ways, using units and degrees, or the ijk, or I can also just use brackets, in which the first space represents I, second j, and the last one k. We can do the same thing for vector B. Notice that in the brackets there's no third space, indicating that there is no k component. Now we can find the resultant, the addition of vector A and vector B, by simply adding all the I components and the j components. We can also write it using brackets. And we can also use units and degrees. To find the length of vector r, we use a symbol with the absolute value signs around vector r. This represents the magnitude of r. Therefore, vector r, the length of vector r is equal to the square root of rx squared plus ry squared, which in our case equals a square root of 30 squared plus 40 squared. which is just 50.